Abiotic. An abiotic factor is non-living part of an ecosystem that shapes its environment. In a terrestrial ecosystems, examples might include temperature, light, and water. In a marine ecosystems, abiotic factor would include salinity and ocean currents. A non-living condition or thing has climate or habitat that influence or affects an ecosystems and the organisms in it. Abiotic factors can determine which species or organisms will survive in a given environment. These are the examples of abiotic: water, air, soil, sunlight, and minerals. Abiotic component. In biology and ecology, abiotic components or abiotic factors are non-living chemical and physical parts of the environment that affect living organisms, and the phenomena associated with them underpin biology as a whole. Abiotic resources are resources that are non-living. These resources fall under the longer category of natural resources, which occur naturally within the environment and aren't created or produced by humans or act. Abiotic factors as non-living physical and chemical elements within the ecosystem. Resources of abiotic factors are usually obtained from the atmosphere, lithosphere, and hydrosphere. Biotic resources. Biotic resources are resources or substances which are derived from the biosphere, like living things, and from forests and the materials derived from them. These mainly include fossil fuels like coal, gas, petroleum. The examples of biotic are forests, animals, birds, fish, and marine organisms. Biotics describe living or once living components of a community, for example organisms such as animals and plants. Biotic may refer to the condition of living organisms. Biotic components also include the waste from living things and dead organisms. Biotic resources includes all living resources found in the marine environment, be it microscopic or macroscopic. For the marine fauna, it comprises the vertebrates, fishes, marine turtle, whale, porpoise, manatees, among others. Commercial resources. The vast ocean has many commercial uses. Among them are for navigation and transport. And furthermore, it provides a reliable supply of affordable aquatic food products with greater access to markets across the developing and developed world. And the most commercialized forms of commercial energy sources are electricity, coal, and advanced petroleum products. Commercial resources. Importance of commercial in aquaculture. It is suggested that commercial aquaculture can contribute significantly to food security, providing employment and income generation to those in developing countries. The energy sources that are used to generate electricity and that are available in the marketplace with a specific price are known as commercial energy sources. Importance of marine resources. They often serve important ecological functions, provide coastal protection, and are critical resources for food, energy, tourism, and economic development. Marine resources are materials and attributes found in the ocean that are considered to have value. And the three important marine sources: fish and seafood supplies, oil, gas, minerals, sand, and gravel. Use of living marine resources covers the exploitation of marine species by man for food, feed, fertilizer, or the production of other products of value or use. and includes activities such as fishing, mariculture, and hunting. In many parts of the world, such marine coastal systems are under stress or are threatened from a variety of sources, both human and natural. Marine resources are physical and biological entities that are found in seas and oceans that are beneficial to man.
Ecosystem integrity. Ecosystem integrity is generally used to refer to the completeness and the functionality of an ecosystem and its ecological processes, particularly in relation to its natural state. It allows for the provision of supporting ecosystem services, which in turn are the basis of important regulating, provisioning, and cultural ecosystem services that are crucial importance for the humans. Whereas the benefits provided by oceans, seas, environment. More intact ecosystems support higher biodiversity and reduce extinction risk, while more degraded ecosystems support lower biodiversity and have a higher extinction risk. Ecosystem integrity can be evaluated in different ways, such as through the presence of ecologically functional population of species within sufficient quality and extent of habitat. This figure shows the ocean, seas, marine resources, and human well-being nexus. An enabling environment comprises, and marine resources are important to all people, vulnerable group, including the poor and the indigenous people, with a high dependency on natural resources and ecosystem services, may have their well-being specially tied up to these benefits. An increase in human well-being is frequently generated at the cost of ecosystem integrity. It can also potentially reduce the negative anthropogenic impacts on the marine environment. For example, due to a more sustainable use of resources, changes in production, consumption patterns, improved management and control human activities for which good governance and an enabling environment are required. The ocean, seas, and marine resources support the human well-being of all people by contributing to the poverty eradication, food security, the creation of sustainable livelihood and jobs, human health, and protection from natural disasters. The following examples are the importance of oceans, seas, and marine resources for human well-being. Over 3 billion people depend on marine and coastal resources for their livelihoods. Fish provide 4.3 billion people with at least 15% of their intake of animal protein. At least 90% of the volume of global trade is seaborne. Approximately 50% is all of the international tourist travel to coastal areas. In some developing countries, notably the small island developing states, tourism can be account for over 20% of the GDP. The global ocean-based economy is estimated at between 3 to 6 trillion US dollar per year. Ocean capture and store about 30% of carbon dioxide produced by humans. The mangroves and coral reefs offer shoreline protection. The global coral reefs protect around 150,000 kilometers of shoreline in more than 100 countries and territories. Marine phytoplankton produces 50% of the oxygen on Earth. This table shows the drivers and pressures of important classes of threats affecting the nexus. The important classes of threats identified are climate change, marine population, unsustainable extraction of marine resources, and physical alteration and destruction of marine and coastal habitats and landscapes. The negative impact of climate change and other threats are already felt in coastal areas around the world and are expected to increase. The adaptation of the drivers, pressure state, impacts responses framework which intend to organize information about the state of the environment and reflects the complex chain of cause and effect in the interaction between society and the environment.
Effects of anthropogenic activities. Human activities affect marine life and marine habitats. So, ocean population comes in many forms, but the largest factor affecting the ocean is plastics. It can kill fishes, birds, marine mammals, and sea turtles that can wipe out entire species. Overfishing. This is the removal of species of fish from the bodies of water, so it can serious threat that causes the loss of fish. Habitat loss. It can affect the marine biodiversity, abundance distribution, and interpopulation dynamics, and the entire ecosystem are altered by the loss of habitat. The introduction of invasive species, a non-native species that can be harmful and it can be a threat to a native species that can cause extinction. Zebra mussel is an example of invasive species. So this has a negative impact to the ecosystem by harming native species. So they compete with their feeder like starving them. Climate change due to anthropogenic gas emission. It leads to rising ocean temperature that can cause coral bleaching. Effects of climate change. Change in ocean temperature, change in ocean salinity, changes in stratification, reduction of oxygen level, increasing acidification of ocean water, increased flooding and inundation, coastal erosion, and coastal squeezing, saltwater intrusion in coastal aquifers, melting of permafrost contributing to release of methane, decreased capacity to absorb and store greenhouse gas emissions, decline and loss of marine species, changes in species range and survivorship due to changes in habitat and living conditions, change in resilience and adaptation capacity, changes in migratory pattern of fish stocks, degradation or destruction of marine and coastal wildlife habitats, reduce wild food fish availability,